Hello everyone, I am Siddharthan. Currently, we are in the second module of our deep learning course where we are discussing about mathematics for deep learning. In the second module, the current topic that we are going to discuss is central tendency. The previous video was about the conceptual aspects of central tendency, and we have also tried to understand what is meant by mean, median, and mode, and how this is exactly used in deep learning. So in this video, let's try to do a hands-on on this where we try to take a set of numbers, calculate the mean, median and mode of those numbers and also do the same with the data frame. So we will consider a sample data set, load that to a data frame and see how you could kind of calculate these values, do a visualization on the graphs with, plotting those mean, median and mode values, and also how you can do a data imputation. So how you can replace the missing values in a data set using the mean value, median value and also the mode value. So this will be the agenda for today's video and let's get started. So for this particular exercise, we will need a set of libraries. So those are NumPy, Pandas, SciPy, Matplotlib, Seaborn, and scikit-learn. So these are the things that we would need. And you can do this installation by just uncommenting this line. So I've already installed these libraries. So I'll just like comment this and run this. So these are the things that we are going to need. And then I'll import the libraries that we are going to need. So I'll import NumPy as NP first and then let's import pandas as pd, and from scipy import stats, import matplotlib.pyplot as plt, import cborn as sns. So these are the things that we need. So if you want, you can use a scikit-learn to load some sample data sets. So you have the diabetes data set, breast cancer data set, and so on. So you can use like any of those data sets as well. And for our particular use case, we will be using two data set. One is the diabetes.csv dataset and the other one is Titanic dataset that we can load from Seaborn. So these are the things. So first we have NumPy and we're going to use NumPy because it has this pre-made functions and methods to calculate the mean and median for a set of numbers, and of course pandas to load our csv file into a pandas data frame, and from the pandas library also we can calculate this mean, median and mode. And then from scipy we are importing stats which will also give you the mode value, and then we are importing this matplotlib.pyplot to just do a very simple visualization of plotting a data and trying to draw lines for mean, median and mode, and finally we have the cborns for that same plot purpose as well. So let's run this cell. That's going to import all the libraries and the functions that we need. And in the first case, we are just going to take a simple data set. Data set in the sense like just a list of numbers. So I'll say data is equal to some random numbers. Let's say that we have 10, 1, 7, 4, 4, 5, 6, 4. We have let's say another 6, 10, and so on. So it has like a set of numbers in it, right? And it is a list because we enclose it in a square bracket, and I'll try to print the length of this. So length of data, so that's going to say it's 10. So this is like 10 set of values, and in this particular list we are going to calculate its mean, median and mode. So first let's try to calculate the mean value. So I'll call this a mean and say that mean underscore value. So we're going to save this mean value in this variable called as mean value, and say np dot mean. So np is nothing but the numpy library that we have imported, and you have to pass the list as the parameter for this np dot mean. And finally you can print this by saying this would be your mean. Put a command, then you just use that mean value. So that's going to print your mean value. So in this case the mean value is 5.7. You can maybe verify that as well. So np dot mean. So the next thing that we are going to do is median. So median is basically you would arrange all this. So mean is just average value. You would add all those things and divide it by 10 because 10 is the total number of values in this case. Median is you arrange all these values in ascending order, and then the center value is your median. If the number of values is even in this case, you take two central values, add it and divide it by 2. So this we have discussed in this previous video as well, so I hope that you remember that. So for median you can just use this np dot median, and the value can be median value, and then print your median value here, and this is your median, your central value. So when you run this, the median value is 5.5. So here we don't have 5.5 here, but the value is 5.5 because we are taking two central values and dividing it by 2. So that's why you're getting this as a median. And finally, let's see how we can calculate this mode. For mode, let's not use NumPy. So instead we can use this stats from SciPy. So the third will be your mode value. So here I can say mode underscore value. So mode is nothing but the most repeated number. In this case, the most repeated number is 4 because it appeared 3 times, whereas 10 and 6 appeared only, let's say, 2 times, right? So I'll say mode value is equal to stats, which is the SciPy module that we have imported. So say stats dot mode, and within the parenthesis pass in the data, and finally say dot mode. This is just to extract the data, because if you just like print this, right? So print mode comma mode value. So this is to get the mode, but when you print this, okay, so I have to put the comma outside this thing. So when you print this, it would say mode result mode np int 64. So we have to get this mode value alone, which is what we are interested in, and this is just the data type, so it's not like that important. So you can say stats dot mode data is we are passing the list for which we need to find the mode. Just say dot mode, so that's going to extract this number 4 alone, and this count tells you like how many times it has repeated. So if you want to print that as well, you can, instead of this mode, you can say dot count, and that will show you like how many times that number has been repeated. So when I run this, it says mode is 4. So this mode is something that we are printing over here, and we are printing the mode value. So this is how you can take a list and try to find its mean value, median value, and mode value. Just pretty simple stuff. So now in our next example, let's consider a data set, a sample data set, load it to a data frame, and then try to calculate these values, the central tendency values such as mean, median, and mode. And as I said earlier, so we'll be using this diabetes.csv. So you can find this all online, but I'll also try to give you a link for this notebook as well as this dataset file, so you can download it from here. So the next part that we are going to do is the same central tendency values. We are going to get it for a data set. So first part is load the CSV file to a data frame. So these are things that we have done like several times. So I hope that you are well versed with this particular part. So we say that df is equal to df, it stands for data frame. Say pd dot read underscore csv. So pd is nothing but the pandas that we have imported. So we have imported pandas as pd. So I'm saying read csv. So for if it's an excel file, you can say excel. Here we are working with the csv file, so I can just say read csv and pass the files. I can say diabetes.csv. So this particular notebook, central tendency python.ipynb, this and the diabetes.csv are in the same folder. I can just say diabetes.csv. If it's in a different folder, I would give the entire path of this. So otherwise you would get file not existing error thing. So I'll run this, and you can try to print the head of this data frame. So you can, it would give you the first 5 rows, simple stuff. And now let's see how you can calculate the mean, median, and mode value. So we know that mean and median values are basically used with numerical columns, and mode is basically used with categorical columns, right? So what we will do is calculate the mean value and median value for age, and here outcome is a categorical column. It only has like 1 and 0, which is basically the target variable. 1 stands for a person being diabetic, 0 for a person being not diabetic. So here I'll say you know calculating mean and median for age column. So here I'm going to say, or maybe we can do this for BMI column as well. It's like, let's say, again, both are the similar example. This is for mean and median for BMI. You can also do this for age and other. Most of these columns are like integer and numerical columns. So you can do that as well. So here I'll say mean BMI. Again, you can do this for age as well, so no issues in that. So I'll say mean BMI is equal to df is my data frame, and I have to pass this entire column, which is BMI. So it's an uppercase letter here, so I would say this BMI and say dot mean. So this is going to look at this df BMI column. So it would extract all the values in the df BMI, which is this BMI column in this df data frame, and it's going to calculate its mean using this mean function. So previous case we have used this mean from NumPy, but we are directly performing this mean using the pandas library. So next I'll just do the same thing, but instead of mean I can get the median value. It's basically you arrange all those values in the ascending order, and you would pick the central value. Again, if it's even number, you would take the two central values and just take an average of that. So here I can say median, and mode is not applicable for numerical columns, right? I mean, you would get a value, but it's not like meaningful. So mode, we can go with the categorical column, which is outcome in this case. So I'll call this mode outcome, and this can be called as median BMI. Mode outcome is equal to same thing. So you say df colon, mention the name, which is outcome, and say dot mode. So this, for this last column we are calculating the mode, and put a parenthesis over here. So this would do all those calculations, and finally we can print this. So I can say something like this. So maybe let's use a f string that would substitute the variables. So I can say mean of BMI column is, use a curly braces, and that would replace the variable with the actual value. So we are going to use the mean BMI. I'll just copy this thing and paste it 3 times. Okay, so the next is median of BMI column. That should be replaced with the median BMI value. And finally we have mode. So we have mode of outcome column, right? So I'll say mode of outcome column is mode outcome, and that would print this. So we have this yeah, so mean of BMI column. So this is the data type that's coming out of this mode, but you can ignore this, the last thing. You can just like focus on these 3 lines. So we have mean BMI for this entire data set is like 31.99, and the median value, the central value, is 32. So here the mean and median are kind of like close to each other. There is a chance that it kind of forms a uniform distribution, as the values are like pretty close to each other, like almost exactly the same. So let's come to that later about understanding the distribution of mean and median. So it would be an eventual video that I would probably publish. So but in this case the mean and median values are like pretty close to each other, and we see that the mode of outcome column is 0. That means like you know uh, 0 is the value that is like repeated most number of times compared to 1. So if you just want the 0 alone, right, so this is coming from this output thing. So instead you can just put a 0 here. This is like getting this one value alone. So if I just show you, this would look something like this. Mode outcome, this is how the data is going to look like. So 0, so 0 means like this is kind of a serial number or an index number. So if you want to get only the number, only the value, you can say of 0. So when you run this, it will just like give the value. So now when you run this, so it's not going to give you that next line. So here your mean BMI is 31.99, median of BMI is 32.0, and your mode of outcome column is 0. So that's how you can calculate this on a data frame. And of course we have the df.describe, so that would give you the descriptive statistics of your data set. So when you run this, for each of these columns it would give you the counts, how many values are there. So totally there are like 768 values. You have the mean of each value is given here, and your standard deviation minimum value. 50th percentile is usually your median value. So 50th percentile means like 50 percentage values are like less than this particular value. So if you take this BMI, right, so here 50th percentile value is 32. So this is not percentage but percentile. So what this means is, out of the 768 data points, half of that 50 percentage of the values are less than 32, and 50 percentage are like more than 32. But it's usually learned as or considered as that 50 percentage are less than 32. So this also acts as your median, because this is the central value, right, as this is exactly in the 50th percentile. So this also acts as your median value. You can consider this as your median value. And then we have 75th percentile maximum values and so on, but we are just focused on this mean and this median value, which is the 50th percentile value. So this is how you can take a data frame and try to calculate the mean, median, mode. So this is how you can do it separately, but if you want a consolidated view, you can do a df.describe. So now let's again take up sample data, maybe the data that we have over here, and calculate the mean, median, and mode value, and do a data visualization on that. So I'll say this as data visualization. Let's convert this to a markdown cell, and let's say data has some values 10, 1, 7, 4, and then all those values, and let's say that we are calculating the mean, median, and mode. So I'm just going to copy this value. So we have mean value, and then we have median value, and finally we add mode from scipy, mode value stats dot mode data. Okay, so this is the data and we have calculated the values. If you want to print that, you can just like do that as well. So we have uh, mean value, median value, and mode value for this particular list of numbers, right? So mean is the average, median is the central value, and mode is the most repeated value. We have mode value. Okay, let's print this and we get the values as 5.7, 5.5, and 4. So now let's say, so we are going to do a plot using Seaborn. So we're going to do a histogram plot. So I'll say plt dot figure and say fixed size. Fixed size is basically what's the configuration of the size of the figure or the plot that you want. So for fixed size, I'll say 5 comma 5. Again, you can play around with this. It's not like that important. So plt dot figure size, and then I'll say sns dot histogram. So histogram basically has some bars in it. So for this case, histograms is a good plot. So I can say sns dot hist plot. So that's going to give me my histogram, and within that we have to pass the data. Data is the data list, and then we can also create bins here. So I can just like give some numbers in it. Let's say I'm using like 7 bins, and kd is equal to true. These are some parameters that we can do. So kd basically stands for the kernel density estimation, something like that. So I don't exactly remember the exact term, but it's like this kernel density estimation is what we do there. And you can also mention a color. So I'll say the color is blue, or yeah. So we have data. Bins is like how many bins you want in your plot. So this is my histogram plot, and the next part is we can add vertical lines for mean, median, and mode. Okay, and now I can say plt dot ax, and this axis we have this v line, or basically your vertical line. So the first vertical line I'm going to use is my mean value. So mean value that we have calculated. So first we build this histogram with this list, and later we draw this mean, median, and mode value as lines, individual lines. So line style, to distinguish them, we are going to give like different styles for this. So let's say it's kind of a dotted line for mean, double dashed line. And also give the line width as well. Let's say line width is 3, or we can use like same line width of 2 for all those cases, and label this as mean. So on the left side we would have all these labels. So I'll just copy this, paste it a couple more times, and replace this mean value with median value, and finally mode value. And let's say in this case I want to represent this with just a hyphen. Let's see if dot works well. If not, we can change this later. Yeah, line width is 2, and then we have median over here, and finally we can label this as mode. So we have mean value, median value, and mode value, and say plt dot legend. So this would give you the labels on top. So we have plt dot legend, and give a title for this as plt dot title, and within this I can say my mean, median, and mode. So this is my plot title, and finally I can say plt dot show. Getting an error, so dot is not valid. So you can use hyphen, double hyphen, something like this. Maybe I'll just use this hyphen and dot. I'm not sure how this hyphen and dot is going to work, but let's see. Okay, let me use sky blue here, and just a hyphen, maybe that's fine. Okay, so we have the line. So we have mean, median, and mode. Let's maybe differentiate these with colors. Let's say color for this is red. So your mean line would be represented by red color. Your median value, let's put blue there, and then for mode value, let's use green color. Okay, so we have these things. So mean is represented by this like dotted lines, red color line. So this red is my mean, which is about this value is like 5.7, you can say like it's toward that, and median value is like 5.5, so median value is like dark blue color, which is like around this thing, and value 4 is your mode, which is represented in green color. So here we have like different, we have a histogram plot with all those distribution and so on, and then you have this thing. So the mean value and median value and mode value are like represented by lines and so on. So this is how we can just like do a simple visualization. So this is just to see like in your data distribution how your median, mode and mean value are looking like. So in the next use case that we are going to do, let's again take another example with some missing values in it. So for that we can consider the Titanic dataset that where we use it to predict the survivor of Titanic, right? So let's use that and try to replace the missing values with, let's say, mean, median, and mode. So that will be the next use case. So I'll make this a markdown cell and say handling missing values. Okay. So for this, I'll call this data frame as data and say SNS. So SNS is Seaborn. It's something that we have already used to build the histogram plot that we have imported here, Seaborn as SNS. It also has some sample data sets. So in that, I'm going to use load dataset. And here you can pass the name of the dataset as parameters. So I want to use the Titanic data. So I'll run this and say data.a, and it would give you the things like survived, passenger class, sex, age, and so on. So if you want to understand, so here this deck has some missing values, and there are like quite a few missing values there. So if you want to understand like what are all the missing values present here, you can use this thing. So you can say data dot is null. That means like the null values dot sum. So when you run this, that's going to find the missing values in each of those columns, and it would give you the sum over here. So we are basically finding the missing values here and just giving a column wise sum for this. So surveyed 0, that means there are no missing values there. So this is going to count the missing values, right? So in this case, this three columns as the value 0, that means like no values are missing there. Age column as the number 177, that means like 177 rows as missing values in this column age, and so on. So in the deck we have 688 column that are like missing, and then this is like what we have. And age, as you can see, it's a numerical column, right? So age is a numerical column, 22, 38, and all those stuff. So here we can replace it either with mean or median. And then you have missing values in this embark town, which also seems to be a category. And then you have deck is also seems to be a category. So let's see. And then you have embarked is also like seems to be a category. So if you want to look at the individual categories, you can do something like this. I'll say data, uh, mention a column. So let's consider this embarked column that has like two missing values. So I'll say embarked over here, dot unique. So that would give you the unique values that you have. Sorry, should be 1n. So you have unique values as SC, Q, and NAN. NAN is the missing values, but yeah, apart from that, you have SC, Q. Okay, and then we have the age values and so on. So let's also see the total number of rows here. So the total number of rows is 891. So if you see this deck, there are like 688 values are missing. That means like we can basically drop this column altogether, because out of 899, 688 column rows are missing. So it's better to not use this. So instead what we will do is try to see how you could replace this age column, missing values in age column 177 numbers, with mean as well as median, either one of those, and also see use this embark the thing. So you have two missing values. So instead of dropping these rows, you can see how you can replace that with mode value. So this is what we will try to do. So we already know, right, so how to calculate the mean and median of a data frame. So you can use this df, the data frame name, and within the square bracket you can say the column name, say mean, median, or mode. For mode you can put a 0, and that's going to give the values, right? So we can do the same thing. So I can say data, and within this I can say age. So age is in lowercase letters. So I'll say age. So data of age is equal to, again mention data of age. I'll explain you the syntax for this, but let's say fill NA, and the data I'm going to fill this with is data age dot mean. Let's try to understand this. So here we are taking this column data age using fill NA. Fill NA is nothing but NA is like not available or missing values. So we are going to fill the missing values, and how we are going to fill that missing value is basically with the value that we are passing it over here. If you put 0 over here, all the missing values will be replaced with 0. But in this case, we want to replace it with mean, right? So instead I can say df column, where in this case data of age dot fill NA. So the missing values with mean value. Okay, so that's going to replace the missing values with mean value and reassign it to this age column. So it's basically take all the values in this particular column, look for the missing values, replace with mean. So now you don't have any missing values here. Put it back to this age column, and that would do this thing. And if you want to replace this with median, and again in the previous video I have explained you that if your data set has a lot of outliers, it's better to replace it with median. If it doesn't have any outliers, then you can go with mean, because mean is affected by outliers and median is not affected by outliers as we are arranging the data. So I'll show you the code. All you have to do is like replace this mean with median. If you want to replace the missing values with median, you can uncomment this line. And if you want to replace it with mean, you can just like just like use this line. So if you are using median, comment this line and use uncomment this line. If you want to just go with mean, you can just like leave it as it. Okay, so the median example, I'll just like leave it as it, so that I hope you understand this. So in this case, we are taking the age column, replacing the 177 missing values in the age column with mean. If you want to, let's say use median, you can comment this like this and do this thing. Okay, but for now let's replace this with mean. So now we have this, we have ran this successfully. Now let's copy this again and try to run this, and now you don't have that 177 values over here. So now all the values in this age columns are replaced with the mean value that we have detected. So the next example is let's take this embark. Let's not consider this deck example to replace with mode, because it has like several values missing. Let's just take this embarked column. It is also like pretty simple to what we have done over here. So I can simply say data of embarked. Here we are reassigning this to this column itself, so that's why we are using this thing. So data of embarked is equal to data, again mention the same thing and say dot fill in a, and you have to say the same thing that we previously used. So we said something like this, data of column name dot mode, and put a 0 to get that exact number. So I can say fill in a data put embarked dot mode, put a parenthesis, open and close parenthesis, and put a 0 towards the end. And then let's run this, and now you can again print this thing. So that would give you the values. Like now if you see embark doesn't have any missing values, age doesn't have any missing values, and so on. If you want to exactly know the values that are getting replaced with that, you can print this data embark dot mode before replacing that. You shouldn't do this after replacing that, because you have already edited the data. Similarly in age, before filling this, you can just print this part alone to basically look at what's the exact value that you are replacing with. But this is the idea. So this is how you can use the central tendency values like mean, median, and mode to do a simple data imputation, where mean and median can be used for numerical columns and mode can be used for categorical columns. So here we basically did three things mainly. So we uh, you know consider just a simple set of numbers, try to calculate mean, median, and mode for it. We have also seen how you could do a simple visualization, put it through a histogram plot, draw the lines of mean, median, mode, and so on. So that's one example. And then we have also considered how you could calculate the mean, median, and mode for a data frame with a sample diabetes data set. And finally, we have seen how you could do a data imputation with the center tendency value, which basically means replacing the missing values with either mean, median, or mode. So I hope everyone is clear, and that is all from my side, and I'll see you in the next upload. Thanks for watching.